The only thing that's daunting, or at least me personally, about like mathematics and continued study in mathematics, just math, not
Mhm.
getting physics in here, is simply the fact that after a certain level, again, you can correct me if I'm wrong, this is just what I think, but after a certain level, it just gets incredibly abstract. Like it gets so just vague. It's all in your head. Like you can't actually make sense, or I guess you can. That's wrong phrasing, but like a lot of the times, like a lot of problems, especially when we're dealing with like 4 and 5 and 6 dimensions, like it's all just in your head. Like you can't really put it on paper or even sometimes visualize it. So
Mhm.
how do you overcome that barrier, or is that something that you enjoy? The fact that there is lack of visualization and it's all in your head.
Yeah, that's really interesting. That it's interesting to hear you how you frame it. Can I
Mm-hmm.
ask, have you guys taken linear algebra yet in your development?
Yeah.
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 So, for anyone who's listening who hasn't done it, I mean, linear algebra is the study of linear transformations, and in one dimension, those are relatively simple, like y equals 2x plus 1, for example. But one of the things that we do is we try to generalize that to a general linear transformation between a larger number of dimensions. And so you're right to phrase it. There becomes an amount of abstraction that happens. But at the same time, when you work with these tools a lot, you start to see, you build an intuition in that domain. Like, for example, you'll learn how to do, I talked about projections already, we'll learn how to do projections just, for example, in 2 dimensions. And then you can ask a question, well, what does a projection look like in n dimensions onto some n minus one dimensional hyperplane or something crazy like this? And those sound really weird, but if you're grounding your intuition and your mental pictures and things that you do understand, I think it creates an avenue to be able to understand those concepts. And a lot of higher level math, when you're trying to wrestle with something that, you're right, might seem new and big and abstract and challenging, is that you want to think through it in terms of concrete toy examples that illustrate the key intuition. And then eventually you see the forest for all the trees that are sticking in front of you. But there is
Mm-hmm.
a lot of trees. I will acknowledge
Very
that.
many. Very many.
When we do like do projections from like an n dimension down to an n minus one, you can kind of just think about it as if it was like 3 dimensions to 2 dimensions, even though it's not the exact same thing, but that's what's
Mm-hmm. Mm-hmm.
happening.
The
Right.
idea is still there, but the thing is, especially like in our class, and I think this should be with all multivariable classes, is that they teach you from three. Like everything starts with 3 dimensions because you can visualize that, right? And like if we're talking about projections for this example, it's 3 to 2. You like we're never really dealing with 4 dimensions to three because there's no way of visualizing what that image would look like. So I guess I do actually see your point, Parker, where like we are given an idea with 3 dimensions and then we can apply that same logic to n dimensions, right? But
Yeah.
I guess this kind of brings up a question in my head where is there any particular like a theory or something, again I'm not quite sure, that exists for 3 dimensions but is different when you start adding dimensions. Like when you start adding dimensions, like the theory changes depending on the
Mm.
number of dimensions or something like that. Like, is there something like that?
Yeah, absolutely. So it is worth noting that your general sense is true, that when you jump up from, let's say, 1 dimensions to 2 dimensions, things get a lot harder. So the classic multivariable example of
Yeah.
this is the concept of a limit. So in 1 dimension, if you want to approach some point, you can come from the left and you can come from the right. There's only two options. So it's
True.
pretty easy to do. But as soon as you go to 2 dimensions, then you're stuck with the issue that you can approach it from any, like infinitely many directions, but you can also approach it from different paths that weave around. And there's this large part of multivariable calculus that you have to be really precise about. What do you mean by a limit?
Mm-hmm.
That, for example, the limit along two different paths that even end up being tangential can have different values. Like, it's kind of crazy. Okay, so that's going from 1 to 2. But then, well, what happens if you go from 2 to 3 or 2 to 700?
Hmm.
A lot of the complexity is not that different. You might talk about the distance between 2 points. Previously might have been a square root of a sum of squares. You just have more in the sum than you did previously, and so forth. So a lot of the time, it's the case that after you've gone from 1 to 2, that's just as difficult as going from 1 to n. And different teachers sometimes, like you talked about how your teachers were really presenting stuff in 3 dimensions. I sometimes do that, but sometimes I'll just generalize right to n dimensions and just be there. That's not always the case, though. There are definitely times where there's weird things that occur in only specific types of dimensions. So, for example, you can ask about maps between spheres, and there's all sorts of interesting things that happen here where things only work in certain types of dimensions. I even remember in my thesis, there was this one weird thing where, for some reason, dimension 6 mattered. And then after that, it sort of stopped mattering for whatever weird reason of the details of it.
That's an interesting one.
And then somehow this sort of skeleton that only happened in 6 dimensions was all that was interesting. And then after that, yes, there were more dimensions, but they stopped being interesting. But you had to get sort of something specific to make that point precise.